Okay, guys, so in class today, we talked about dilations on a coordinate plane. We talked about the distances from the center to the each individual point to make an entire shape larger. And we saw a pattern when we did a dilation. We found out that as long as our center of dilation is the origin, all we have to do is multiply our points. So I'm going to quickly go over these notes with you guys, so that way tomorrow we can do practice on dilations on a coordinate plane. So to dilate a figure on the coordinate plane, multiply the x and y values of each ordered pair by the given scale factor. So when you multiply by a scale factor that is greater than 1, the shape becomes larger. The shape becomes larger. Or the other term for that is just enlarges. It enlarges. When you multiply by a scale factor that is less than 1, the shape decreases or becomes smaller. The word for that is the shape shrinks. So a shape can enlarge or shrink based off of the scale factor. If I was to give you two shapes that have been dilated, and this is what we've been practicing in our warm-ups, we need to find the scale factor. So to find the scale factor, you want to divide your new ordered pairs by the original ordered pairs, or the image ordered pairs divided by the pre-image. So whichever shape is the new shape, you want to take those ordered pairs and divide them by the original ones on the original shape. And when you do that, you should get the scale factor, and you should get the same scale factor each time. Okay, so our number one here is similar to the one that we did in class today, where we are multiplying by a scale factor of 1/3. So we have A, B, C, D. Those original points, we want to find the original points here, so that way we can multiply them by the scale factor. So our original point A is over at -6 up to +3, so it's -6, 3. B is over at 6 and up to 3, so this is 6, 3. C is over to 6 and down to -3, so this is 6, -3. And D is over to -6 down to -3, so it's -6, -3. So I need to multiply these numbers by -3. If I did sorry, not -3, I'm so sorry. Multiply these numbers by 1/3. So if I did 6 times 1/3, that would be the same as 6 over 3, which is equal to 2. And if I did 3 times 1/3, that would be 3 over 3, which is equal to 1. And then I just need to pay attention to whether it's negative or positive. So all my 6's will become 2's. All my 3's will become 1's. So my A prime, B prime, C prime, and D prime. -6 would become -2. +3 would become +1. +6 would become +2. +3 would become +1. +6 would become +2. -3 would become -1. And -6 would become -2, while -3 would become -1. So these are my new points. We should see that when we plot these points, our rectangle should get smaller because our scale factor is less than 1. So we're going to plot A prime, -2, 1. We're going to go over to -2, up to 1. That's my A prime. B prime is 2, 1, so I'm going to go over to 2, up to 1. That's my B prime. C prime is 2, -1, so I'm going to go over to 2, down to 1. That's my C prime. And D prime, -2, -1. I want to go over to -2, down to -1. That is my D prime. And I can now connect these and notice that my rectangle got smaller. To make sure that I did it correctly, I can see that the side length here is 2, while the side length on the original was 6. So 1/3 of 6 gives me 2. Same thing down here. The new side length is 4. The original side length was 12. 12 times 1/3 is 4. So my side lengths are also being multiplied by that scale factor. So when it says, how can we represent the dilation algebraically? This is going way back to the beginning of Unit 1. Our original points, x, y, are now those points multiplied by 1/3. So it's 1/3 of x and 1/3 of y. So this says compare the ratios of corresponding sides. What do you notice? So if I'm looking at my corresponding sides and my ratios, if I do the new over the original, so this side here is 2, so B prime C prime is 2, and BC, the original BC, we said was 6. So that ratio here simplifies to 1/3, which is what our scale factor was. Just like I said with the other one, if I did D prime C prime, that side length was 4. The side length of the original DC, D to C here, was 12. So as a ratio, 4/12 simplifies to 1/3. Again, our scale factor. And then this said, did the dilation change or preserve the orientation of the figure and the orientation of the vertices? This just means, is the shape still facing the same way? So like when we rotated a shape or reflected a shape, the shape was no longer facing the same way. But the shape is still facing the same way. We didn't turn it, we didn't rotate it. The shape is the same way, it's just smaller. So our answer here is yes, it is just smaller. Okay. So when we dilate, as long as our origin is the center, the only thing you have to do is multiply these points. And now that we've gotten to this lesson, dilating shapes should be so much easier. We don't have to pay attention to the distance from the center to B to get to our new point anymore. All we have to do, as long as our center is our origin, all we have to do is multiply. Okay? So I want you guys to try and do 4 on your own. With the scale factor of 2, if you feel comfortable giving yourself a challenge. If you are one of my kids that you kind of got it today, you understood it, you were waiting for other people to be quiet or waiting for other people to like catch up so you could keep going, try and challenge yourself. Do number 5 as a challenge. This is a challenge because the scale factor is 3/2. So it is greater than 1, but it's still a fraction. Okay? And then I do want to come down here and just practice finding the scale factor real quickly. So to find the scale factor that was used in the dilation, again, I can either use the points or I can use my side lengths. So if I'm looking at my new side lengths, M prime, L prime, I'm going to write it M, L prime, M prime. That side length is 1, 2, 3, 4, 5. My M to L, sorry, there should be L to M if I wrote it that way up top. That side length was 1, 2, 3, 4. So as a ratio, I cannot simplify this anymore. This is my scale factor. My scale factor is 5/4. Same thing with this one. So I'm looking at my side length down here. I'm looking at the horizontal one because I don't want to do diagonals. Diagonals will mess us up. So my P prime R prime has a side length of 1, 2, 3, where the original PR had a side length of 1, 2, 3, 4, 5, 6, 7. Look, I lost count. But it started here, went all the way over to 9, so I know that it has a side length of 9. I'm going to write that as a ratio. So 3 over 9, I can simplify that by dividing both numbers by 3. 3 over 9 simplifies to 1/3. So my scale factor for this one is 1/3. And lastly, if I was just giving points, this is my new over my original. So if I'm looking at just my x's, I want to do 6 over 9. That's my ratio here. Or I could look at 8 over 12. Both of these can be divided by 3. So this is equal to 2/3. Both of these can be divided by 4. This is also equal to 2/3. So my scale factor here is 2/3 for this one. Okay. So again, I want you guys to try number 4, or if you are good and ready to go for a challenge, you want to prove to me that you understood what we did in class and understood this video, do number 5. Try it with a different scale factor of 3 over 2. Okay? Bring this paper back to school tomorrow. Make sure you bring this paper back to school tomorrow. If you guys have any questions, please let me know. We're going to be practicing dilations all day long tomorrow. Bye, guys.